Hello and welcome everyone to the latest City, University of London, European Social Survey and NatSense Survey Methods webinar. I'm Tim Hanson, a Senior Research Fellow at ESS headquarters in London, and I'll be chairing today's session. We're very pleased to welcome Andrew Mercer, who will be our speaker today. Andrew is a Senior Research Methodologist at Pew Research Center in the US. He leads Pew's research on non-probability survey methods and is also an expert in survey non-response and statistical analysis. His research focuses on methods of identifying and correcting bias in survey samples, as well as on the use of machine learning for survey data. Today, Andrew will be presenting on the current state of online probability-based and opt-in survey samples, based on a Pew study that compared 3 probability-based panels and 3 from opt-in sources. Andrew will talk for about 40 minutes, and there'll be time for questions after that. If you do have any questions, please type these in the Q&A area and we'll go through as many as we can. I'll now hand over to Andrew.
Great. Well, thank you, Tim, for that introduction. And thank you, everyone who's come out to see this talk. Just to reiterate, I'm Andrew Mercer, and I'm a survey methodologist at the Pew Research Center. And I'm going to be talking about some of our latest research looking at online samples, probability-based and non-probability as well. To set this stage, let me give a little bit of background about the sort of line of research that we've been doing at the Pew Research Center. So in maybe the early aughts, it was pretty clear that the writing was on the wall for traditional RDD telephone surveys, which had been the mainstay of how Pew Research Center had been doing polling for its entire existence. And Scott Keeter, who ran the methods department at the time, launched a line of research to try to figure out how we could continue to do high quality, rigorous public opinion research once telephone polling was no longer viable. And there were a couple of possibilities. The one thing that we did was we started our own probability-based panel, the American Trends Panel. The time that was recruited off of a large RDD telephone survey. And the other possibility was non-probability samples. There was a lot of discussion back then that you could get some of these samples, it'd be very cheap, and we could use statistical models to correct for the kinds of selection biases that we see. So we launched a line of research into both. And in 2016, we did a big study to sort of see what the state of things was at that time. So what I'm showing you now is sort of the headline graph from our 2016 report comparing the accuracy of different kinds of online samples. We compared 9 different online opt-in or non-probability samples. And in this graph, I don't know if the mouse is visible here, but those are all indicated by the letters A through G, H, I guess, actually. And then we, as well as the American Trends Panel, so that's the ATP there. And we were looking at 20 different benchmarks. So these are variables where there's a high quality official statistic that we can use as a ground truth. And then we measure a comparable estimate on a particular panel. And we can, the difference between the benchmark value and the estimate is, we call that error. And then we look at, who had the largest errors. And what we saw was that on all 20 benchmarks, there was a pretty wide range. So that the error, the sample with the lowest error was sample I, which had 5.8 percentage points of error on average, which went up to 10 percentage points for sample D down there at the very bottom. And what we see is that the ATP is kind of right there in the middle. Which was not what we expected to find. Most of the studies like this have found that the probability-based samples are consistently more accurate. than the non-probability samples across the board, and that was not what we got here. So that was a little bit alarming to us. And we looked at what might be going on there. So there were a few different things. One is that we saw on 8 of the benchmarks that we had that were related to measures of civic engagement. So these were things like, do you talk to your neighbors? If you've gone to rallies, that sort of thing. The American Trends Panel was sort of down towards the bottom there with 13 points of error. And many of the opt-in samples did much better. On the 12 benchmarks that were not related to civic engagement, and these are more sort of objective things like, you know, do you have a passport? Or do you have health insurance? They're sort of, you know, things that don't have any particular like civic valence to them. We found that the ATP was the most accurate. We also saw that accuracy was a lot worse among Black and Hispanic adults on a lot of the opt-in samples, although one opt-in sample actually did better than the ATP on those kinds of estimates. So this was a big study for us, and prompted us to make you know, a number of changes, first to how we weighted the ATP, and subsequently, we've also changed how we recruit. And we wanted to do a follow-up study to see sort of, okay, where are things now with respect both to the American Trends Panel and all the evolution that it's seen, as well as to other probability-based panels and non-probability samples. So what's changed since we did this in 2016? So since then, you know, we've changed a lot about the ATP. But the whole probability-based sample space in the United States has also grown. There's many more commercial options available now. And the opt-in technologies have also changed a great deal. So now we've got, you know, sample aggregators, and there's a whole bunch of technologies that are in use that weren't at the time. And we've also seen 2 big polling failures in US presidential elections since we released that study. So you know, where are we now? So checking back in, just to sort of give you a snapshot of what the situation looks like in the United States. This slide here is from a report that my colleague Courtney Kennedy led, that just is looking at the number of US pollsters using different kinds of methods, how much that's changed since 2000. And so this graph on the left here, right, shows that there were 28 pollsters in 2000 who were using live telephone polls, which is down to 22 in the 2022 election. In that middle panel, this is the number of online opt-in pollsters, has gone from 1 in 2000 up to 46. And importantly, this is the number of pollsters. If you look at the actual number of polls, these differences are even dramatically larger, because people who are doing online opt-in polling are also able to do a lot more polls. So this is, you know, this sort of maybe almost understates the changes that have happened if you're looking at things at the polling level. And on the right, the same thing there. Probability-based panels have, you know, started out in you know, very little use, but we've seen they're now increasingly commonly used in public opinion polling. So what does this mean? So we wanted to design a new study to get at these questions. We commissioned 6 different online samples, all coming from different sample providers. We gave them all the same 15-minute questionnaire, and that included 28 benchmark variables that we could use to measure accuracy. We used the same standard weighting scheme for all of the samples. It's the scheme that we use on the American Trends Panel, because we wanted to be able to say, you know, to rule out the, you know, weighting differences as a explanation for differences that we saw in the results. And importantly, I think there have been a number of studies like this in the past. Many of them are pretty old at this point. But also, this is the first that I'm aware of to compare multiple probability-based online panels to one another. Almost all of the studies like this that have been done in the past, there's been one probability-based panel and a whole bunch of opt-in panels. And we never really get to see, well, how do the probability-based panels compare to one another? Are they actually giving comparable results? Other thing we wanted to do is we really wanted to be able to look at subgroups. So we made sure that all of these samples had a large sample size, approximately 5,000 completes each, so that we would have sufficient cases within subgroups to be able to look at accuracy. So what did we find? So this graph here has kind of the major top line finding from the study. So this is showing the average absolute error on 28 benchmark variables for GenPop estimates among adults. And the two top bars there are the mean error across all three opt-in samples, which was 5.8 percentage points. And below that, the mean error for all three probability-based samples, which was 2.6, right? And when you look at the individual samples, there's some variability, but the actual level of error was fairly similar across all of them. This next graph, so that's sort of the average. What did the distribution look like across questions? So what this graph here is showing is each of these little squares represents one benchmark variable. So these are basically histograms showing how many variables on each study had a certain amount of error. And what we see, I don't want to get too bogged down in the slide, but what we see is on the probability-based samples, most of the benchmarks have error that's sort of bunched up close to zero, ranging between 0 and 5 percentage points. You get a handful of variables on each of these samples that have error between 5 and 10 percentage points. You don't really see any where the average error is greater than 10 percentage points. One important point is when I'm talking about the variables here, a number of these benchmarks have multiple categories. And so when we talk about the average error, the average absolute error for a variable, that's taking the average error for each estimate for a category within a variable and sort of averaging at the variable level. So we're not just looking at, say, the error on the modal category in a benchmark. We're trying to aggregate all of the categories in a given variable, which is a lot of studies haven't done that. If we look at the opt-in samples below, we don't really see the same kind of distribution, right? You see there are some variables with error bunched up close to zero, but there's a much greater spread. There's a lot more variables in that 5 to 10 percentage point range. And you've got a few variables that, let's see, I think my head is blocking opt-in sample 3 over here, but right, that get up quite high. Opt-in sample 3 does have something that looks a little bit more like what we would expect in terms of this distribution. But we really see a much larger variability in the magnitude of errors in the opt-in samples. This is just sort of another way of looking at it, where we're showing the orange dots here are the average error for each of these variables on the probability-based panels and in the opt-in samples. And there's a lot going on in this slide. The main thing I just want to highlight here is that for the most part, we see that the variables that have high error on the probability-based panels, the level of error on these variables is fairly similar within each sample type, right? So there's a pretty clear trend in terms of the blue dots all kind of hang together, even though there's some variability, and the orange dots also kind of hang together as well. And that in general, the probability-based estimates tend to have lower error across the board. But there are two variables I want to highlight and mention specifically, and these are ones where the probability-based samples were consistently across the board had higher error than all of the non-probability samples. The first of these is COVID-19 vaccination status, where the probability-based samples consistently overrepresented people who said they were vaccinated. And the other is turnout, the share who said they voted in the 2020 presidential election. So that was actually the variable with the highest error for the probability-based samples. And suggests that problem that we saw with civic engagement and sort of the overrepresentation of people who do things like vote and go get vaccinated is not something that we have successfully fixed. That's still an issue that we need to address in the probability-based space. So that's sort of the big high-level general population results. But that was not the interesting part of this study, actually. Really, what ended up being most interesting and most unique about this report is what we found about subgroups. So, and here I'm mostly just going to be talking about the averages across the three different types. But here's what we saw. So there were 25 benchmark variables that we had subgroup benchmarks that we could compare to. There were a few that just there aren't reliable benchmarks available. Now, unfortunately, these were also the ones that the probability-based panels do the worst on, turnout and vaccination, and I'm blanking on what the third one was. But I think the pattern that we saw here, that's sort of almost beside the point. On these 25 benchmark variables, so if we look, so here this ages 18 to 29, on the probability-based panels, estimates for 18 to 29-year-olds had on average 3.6 percentage points worth of error, right? On the opt-in panels, it was dramatically higher. It was 11.2 percentage points, right? So the difference, we're seeing much larger error for estimates among young people in the opt-in samples, right? If you look at the accuracy for people who are 65 or older, right, there's almost no difference, right? 2.3 percentage points of error on the probability-based panels and 2.6 for the opt-in. So the error distribution by age, we're seeing a huge difference in the opt-in samples. We do see some difference in the probability-based samples, but not anywhere to the same degree. At the bottom here, we also saw big differences by racial and ethnic groups. So in the probability-based panels, right, we saw that estimates for Hispanic adults had about 3.6 percentage points of error on average, right, versus 10.8 in the opt-in samples. So now we expect in this doesn't really, none of these results are terribly surprising in the probability-based panels, at least to me. I have a good understanding, I think, of what kind of people are harder to recruit, who's, what kinds of non-response patterns we would expect to see among certain kind of groups. But I didn't really have any understanding of what was going on, why we saw such large subgroup differences in the opt-in samples. So we dug into that. And one thing we found was that some of the variables where we saw the largest errors in the opt-in samples were about these receipt of government benefits. So if you look here on the left, these are the estimates for the share who reported receiving food stamps in the last year. And the benchmark is 11% of adults. That's this gray bar, right? The opt-in samples overestimated that share by 19% for 2 of them and 11% for the third. We also saw, the probability-based panels overrepresented these estimates as well, but not to the same degree. Same thing with Social Security, 17, between 13 and 17 percentage points of error on Social Security, unemployment compensation, and then again, my head is blocking the benchmark for workers' compensation. So this is benefits you can receive if you're injured on the job. Very few people actually receive this in a year. The benchmark is only 0.4% of adults receive workers' compensation, but the opt-in samples were overrepresenting that by anywhere from 7 to 11 percentage points. The overestimates for the probability-based samples were much smaller. Now, one nice thing about these benchmarks is they all came from the same source, which is the Current Population Survey March Supplement, which is done by the US Census Bureau. And that meant that in addition to looking at how many people got each of these benefits on their own, we could also see, well, how many people got different kinds of benefits in combination. And here is where we found something I think that was really illuminating. So these 3 bars are showing the share who received 0 of the 4 benefits, 1 to 2 of these benefits, and 3 or more of these benefits, right? So about 62% of adults, so the gray bar is the benchmark, didn't receive any of these benchmarks. All of the samples underestimate that, but the opt-in samples were underestimating that by anywhere from 19 to 28 percentage points. Over here on the right, again, I'm going to have to flip this around if I do this as a webinar again. The actual share who received 3 or 4 of these benchmarks is only about 0.1% of all adults, right? And the error on the probability-based samples is all about 0 to 1 in terms of overestimating the share who reported getting 3 or more of these. In the opt-in samples, though, that's overestimated by 6, 9, or 11 percentage points. So this is like, close to 10% of the opt-in samples are saying they get these benefits that are, in fact, virtually nobody in the population actually receives. Now, what's interesting is here's what we get if we look at these differences among 18 to 29-year-olds. So again, if we look at this rightmost panel, the benchmark is still 0.1%. The error on the probability-based panels is only +1 across the board, but in the opt-ins, it's +17, 21, and 21. So this is, almost a fifth of the opt-in respondents were saying they received 3 or more of these. So a lot of these are 18 to 29-year-olds saying that they get Social Security, which is guaranteed for people who are 65 or older in the US. But very, very few young people do receive it. It's not 0 because you can also get Social Security if you have a disability, or there are various conditions where you can get it. But it's very, very few 18 to 29-year-olds actually receive Social Security. And we saw the same thing for estimates with Hispanics, right? Where we saw huge overestimates in the share who were saying they received 3 or more of these benefits. And so these are the ones where we had a benchmark. That's sort of large errors there. If we broadened this out, we also had a bunch of other questions where we just asked, there were yes or no questions. And we tallied up how many people said yes or how many yes answers people gave to these 16 questions. And so this graph here is showing the average share of respondents who said yes to 10 or more of these questions. And on the probability-based samples, right, what we see is across the board for all adults, 1% said yes to 10 or more. And that's pretty consistent across the age groups and across the racial and ethnic categories, where it's slightly higher among Black and Hispanic respondents. But in the opt-in samples, right, we again see this huge differential with 15% of 18 to 29-year-olds just saying yes to a whole bunch of questions, and 19% of Hispanic respondents saying yes to these questions. And, if you think about it, the combinatorics of it, saying yes, being in 10 of these specific categories, you create these just infinitesimally small combinations that just don't really exist in the universe. And we don't think here that looking at that there's just certain weird, rare kinds of people that are being overrepresented in the opt-in samples. Instead, what this looks like is essentially measurement error, people misreporting and claiming to have either received benefits or answering yes to questions where that's not really the true, doesn't reflect a sincere response on their part. And so, the framing that we've kind of adopted at Pew to talk about this is we think of these as bogus respondents, basically, that there's a pool of people in online opt-in samples today who are really, they're not trying to answer questions truthfully. They're essentially trying to get through the survey to get some kind of a reward. And disproportionately, those people are also saying that they come from key demographic subgroups. And so what happens is there's this pattern of error that is dramatically larger, specifically within those groups. And what's also important here is that it's measurement error, right? So it's also not something that we can fix by weighting. It's a data quality issue, and the fact that people are not, accurately responding. And what's important is that we do not see this same kind of behavior in probability-based samples. And I think, I have lots of speculation as to why that is. But at the end of the day, you don't have the same ability to sign up for a whole bunch of different probability-based panels. You may get selected for one, you probably won't, and it's not really up to you when you're going to take a survey. So it's not something that people can exploit to try to earn some kinds of rewards. Whereas, especially in recent years, there's been a huge growth in recruiting opt-in respondents off of these kinds of things like offer walls, where it's sort of like take a survey to win, to get in-game currency in your mobile app, or to get a gift card. And there are some kinds of bad actors who are trying to do this at scale with like click farms and bots and things like that. But I suspect there's also a lot of people who are just trying to get through and get their in-game currency and don't really care about whether or not you are they're actually answering correctly or have any interest in the accuracy of the survey results. So there's sort of a charitable explanation of this phenomenon that is these people really are overrepresented. You can sort of understand how people who are financially disadvantaged and receive various government benefits may also be trying to earn income on opt-in samples because it's an accessible way of doing that. So we did a follow-up study to sort of see if this held when we were looking at something else. So we asked on a different opt-in sample, are you licensed to operate a class SSGN submarine, which for people who don't know is a nuclear submarine operated by the US Navy. At last I checked, there are only 4 in operation. And the number of people who are actually certified to pilot one of these things is not 0, but it's rounds to 0 on a population scale. If you ask this question in a survey and see anything more than a very small number of people saying yes, right, those people are almost certainly misreporting and not giving you a sincere answer. So what did we see? We saw exactly the same pattern of results, right, where people, respondents, opt-in respondents who were ostensibly 18 to 29, 12% of them said that they were licensed to operate class SSGN submarine, 24% of Hispanic respondents, right? So, so we saw exactly the same thing. There's virtually nobody in the population who actually fits this category, but we're seeing large overestimates among 18 to 29-year-olds and Hispanic adults, right? So this is clearly not overrepresenting submariners. Somebody online did ask me if I had considered the possibility that the Navy has just been lying to us all along about how many there actually are. I confess I had not considered that possibility, but we'll have to try to account for that in a future study. So what we're seeing here is a really clear pattern of error. And there's one point that I think is easy to sort of miss, and I felt like online I put this pretty well, so I will just paste it in, is we don't think that the people giving these kinds of ridiculous answers are actually under 30 or Hispanic, right? It's that there are people who are giving bad data across the board, right? So they are saying they all pilot a submarine when it's not true. They are also saying they are 18 to 39 or Hispanic when it's not true, right? So this is sort of measurement error across the board and not just on the sort of main substantive outcomes that we're usually focused on. And I think that it's obvious kind of when you think about it after the fact, but it's easy to sort of miss that just sort of if you're looking at this at a glance. So that sort of brings us to a study that we put out a couple of weeks ago. I had a conversation with Mario Calagaro a couple of weeks ago where he had been talking about our benchmarking study to some decision makers who have to make funding decisions about big data collections. And to them, sort of six percentage points of error on average, like, is that really all that bad? What's the risk? And I mean, for one, these are averages, right? So if it's 6 percentage points of error and you've got a 0 bound, that means that some of these estimates have huge errors, on the order of 20%. So it's very easy to miss that when we're sort of looking at these errors. And so the scenario that happened a couple weeks ago. So what does this mean in practice? What do these kinds of findings, what are the implications for people who are trying to report on different kinds of samples? So many of you may have seen this headline that came up in The Economist in December. So this was an extremely alarming headline. 1 in 5 young Americans thinks the Holocaust is a myth. So this was based on The Economist's poll. It was done using an opt-in sample. And it got just enormous attention across the board, not just in The Economist, but really all over the world. And I think if that was true, it would absolutely be merited. But I looked at that headline, and my thinking was, this is actually exactly what we would expect to see if, in fact, very few people believe this, but you have a large number of bogus respondents in the opt-in sample who are saying they're 18 to 29 and who are answering, just answering yes because they're not paying attention to what they're not trying to answer honestly. And so we decided that we would, actually here, just to sort of illustrate the reach, this is actually a billboard in New York where this polling result was turned up. So the sort of reach for this particular headline was enormous, and it looked to us like this was basically an artifact, a methodological artifact of a data quality problem that we're seeing in opt-in samples. And so we decided to replicate this on the American Trends panel. And here's what we found. And we put this report out now, I think, about 2 weeks ago. So the orange, right, is the original share of opt-in respondents who were 18 to 29 who said they agreed with the statement, the Holocaust is a myth. When we replicated this on the American Trends panel, it was 3%. And again, we saw no difference across any of the age groups. And so this is exactly the same pattern that we saw with the submarine question, with the receipt of government benefits, with the large number of people saying yes to all sorts of questions, except that here, right, this wasn't part of an academic, methodological study. This was a headline that showed up and, spread like wildfire all over the place. That wasn't the only question. We also included, they had a question about attitudes on abortion among young adults. And, consistently in the US, young people are by far the most pro-choice, most in favor of legal abortion. In the opt-in poll from December, almost half of 18 to 29-year-olds were reported as saying that abortion should be illegal or only legal in special circumstances. If that were a true finding, that would be a seismic change in the US political landscape. But when we replicated this question again, we got 23% of 18 to 29-year-olds who held that view on the probability-based panel. And that is a number that is very much in line with almost all of the sort of rigorous research on this topic that we see. So, so that's all of the substantive research. And I guess in closing, I'm just going to kind of talk about a few, bring this back to the question of what does all of this research mean for sort of the question of probability versus non-probability. And I think one theme to me that I think is important is if you think back to all of the old debates about probability versus non-probability, a lot of it was about, non-probability can't be valid because there's no known probability of selection. Proponents of non-probability and folks like Andrew Gelman said things like, that's, nonsense, there's perfectly good statistical theory, and you don't know the probabilities of selection for your probability-based respondents either. And this debate is I think, settled, right? We're not doing design-based inference anymore, even if you have a probability-based sample. I think there's now a much wider spread recognition that we're all basically doing model-based inferences. And the question is, how well are you able to model the mechanisms that are at play behind your, that explain the differences between your survey data and the population? The other piece is that both still have problems, but they're different problems, right? So the probability-based samples, I'm not going to tell you that these are perfect, right? And I think it's clear that we clearly still overrepresent, voters, the most engaged, volunteers. That's not something that we have fixed. But I think that's pretty clearly not a measurement problem, right? I think that a lot of the problems that we're seeing in the non-probability samples, the worst of it right now, to me, does not seem to be about non-random selection or selection bias, right? It's about these kinds of large measurement errors. And those are different. Those take different tools to fix. I think a lot of the historical research, comparing these two has sort of approached from the assumption that once somebody gets into the sample, they're more or less behaving in the same way. And that really does not appear to be the case. I think what we're seeing here, particularly this issue of bogus respondents who are concentrated in certain subgroups, also has some really important implications for blended samples. One of the things people want to do is maybe collect most of your data with a probability-based sample, but then for really hard to reach groups, maybe supplement that with opt-in cases that are less expensive to get. And what this suggests to me, though, is that the very kinds of cases that you would want to, the hard to reach folks that you might want to supplement with are in fact the ones that have these especially large data quality problems. So I think this is something that is going to be an issue for anybody who's trying to blend probability and non-probability samples. And then there's just this question, I think communications challenges, sort of like what Mario was talking about to me. It's the reaction to our replication of this Economist poll has been, it's gotten orders of magnitude more attention than any kind of methodological study we've ever done. And I think it just highlights, this is sort of an instance where I think we were able to show what some of the implications of this methodological research are in practice in a way that's tangible to people who might have to make a decision about, am I going to report a particular poll finding or not? And these kinds of circumstances, it's hard to, you can't kind of engineer these, but I think it shows that we have to figure out how to communicate what the implications of these different kinds of studies are to people, to stakeholders who are going to, either make funding decisions or, write headlines. And then the last question that I think is relevant is sort of, well, what does this all mean for election polls, right? The opt-in samples are overwhelmingly the most frequent kind of poll we see, at least in US election polling. I believe that's, I think, even more true in the UK. And so I've looked at this, other people have looked at this, and for now, I cannot see any systematic difference between the probability-based election polls in the US so far this year or in recent years, and the non-probability based ones. There is no systematic difference that I can see whatsoever, and have looked at it a whole bunch of ways. So for now, I'm sort of cautiously optimistic that this isn't something that's at least currently affecting the sort of top line horse race results. Although it absolutely could in the future. I wouldn't rule it out. But where I do worry is in analyses that try to sort of understand, well, what explains the changes that we're seeing in the horse race? What are we seeing in the polling about the electorate? And I do worry there about the potential for sort of narratives about, for example, and these are big things, how young people are voting or changing, or how Hispanic voters are reacting to the situation. I think it would be very easy to create some narratives that are based on non-probability data about some of these groups that end up actually not being accurate. And so I will leave it at that. And I think we've got time for some questions. Thanks everybody so much for tuning in and sticking around.
Thanks, Andrew. That's a really fascinating talk. So I'm sure everyone got lots out of that and really enjoyed it. Got quite a few questions already, so we'll go straight on to them. I probably won't be able to get through all of them, so might need to be a bit selective as we go through. So apologies if we don't get to your question. I'll ask this one first. So Andrew described the benchmarks as coming from high quality registries and where some of those were gathered through self-reported survey measures. How do you think that the reason for high performance of probability samples were due to sharing much more similar methodologies to how the benchmarks were collected compared to the methodology of the non-probability samples? That is, how much would you think the probability sample's performance was attenuated by shared method error?
I see. In the sense that the benchmarks are themselves probability samples? I think it's not impossible. At the end of the day, I think the sort of the samples, so the probability samples that we do pull things from, like the American Community Survey or the Current Population Survey, absolutely do have, the potential for error. They also have, I think much higher response rates and much more, I think, rigorous data collection than is done for most probability-based or non-probability-based polls. So it's absolutely true that some of the, that there is error in the benchmarks. But I think, our thinking is that these are I wouldn't say that these necessarily reflect the truth with a capital T, right? But that these are the best available data these are probably the closest to the truth that's available to us. I wouldn't have any reason to believe that lower response rate probability-based polls or opt-in polls would be more accurate than any of the sort of benchmark surveys that we're talking about.
Great, thank you. Next question, do you think that attention tests during the questionnaire are mandatory to minimize measurement errors in opt-in samples?
So I think so, but what's interesting is in our own studies, not this study, but other studies, we have found that people who we've been able to classify as bogus respondents also tend to pass the attention checks. Most of the time, it's pretty obvious that somebody is doing an attention check, and I think the people who are trying to earn a reward can see that and tend to pass them. Another sort of related interesting point here on the sort of the yes/no questions that we looked at in our benchmarking study, there were clear differences in terms of the share who said yes to a lot of questions. But there were very few people in the opt-in samples who said yes to all 16 of the questions. So we're also not seeing people behaving in like a uniformly predictable way. There's a lot of enough noise in the data that there's not like a readily identifiable set of questions that I think you could easily use to delineate these kinds of people.
Sure, thank you. Okay, let's see. One more. So have Pew attempted to assess the non-probability panels where the panelists are not compensated for completing surveys, if they exist? It seems likely that even such panels will be prone to error, even without the strong incentive to be a bogus respondent.
So in our benchmarking study, these were all where people are compensated. For the vast majority, at least in the US, for the overwhelming majority of opt-in polls that are in the media, they are samples where people are getting some kind of reward. There are a few exceptions, but they are the minority. So we didn't look at those. It would not surprise me if you do see differences in terms of some of the response behaviors, but that wasn't something that we looked at here. Yeah.
Sure. Okay. Yeah. And there was another question on a similar topic as well. How much bad quality data in opt-in panels can come from bots?
I don't have a good way to answer that question. I think It's very, I think it's clear that there are probably a few different kinds of bad behaviors going on, but at least as somebody who only has access to the eventual data set, I don't have a good way of saying this is a bot and this is a person, answering badly. I know there have been a number of studies by like the Insights Association that have tried to look at that. I don't have those numbers off the top of my head, but yeah, I think it's very hard to know based on just the data that's available to us as a data consumer.
Great, thank you. Regarding your discussion with Mario, did you two come to a conclusion about a certain threshold that would convince most decision makers to choose probability samples?
No, I think it was just a conversation, and it was sort of, yeah, this is a problem. How do you? I don't know that there's a set threshold anyway. I think, there's the notion of something being fit for purpose. How much error would, if you need to make a decision, how much error, it could be that you could have a large amount of error, but it would still inform, if you only need to know if something is, more than 50%, right? And you have an opt-in sample where you get an estimate of 80%, it's probably still over 50% if that's your decision threshold, right? So I could see how for, like market research purposes or things like that, that might be more than adequate. Yeah, there's not a good one size fits all there. I think really the challenge is just communicating the results of methodological studies in a way that people who are not methodologists can understand.
Great, thank you. Slightly more technical question maybe now. So these findings are very interesting. We see similar patterns for the measurement of far-right attitudes in Germany, but found that when controlling for measurement error using methods to investigate measurement invariance for multi-item measures, we tend to find scalar invariance, but later means tend to systematically differ. Do you have data on that? And what happens if you exclude those respondents that show suspicious response patterns?
So there's probably, the data probably exists in our data. One of my personal frustrations here is that I've spent the last 10 years focused on selection bias, and now I've got to learn all of these measurement statistical methods that I have thought I could safely ignore. So the answer is no, but this is the kind of thing that I think we're going to start looking at. I will say, for those people who do want to look at this kind of thing and already know what they need to do, these data sets are available for download on the pewresearch.org website. They do have batteries and scales and whatnot that you could take a look at. So if other people want to try to do some of these analysis with this data, that would be fantastic. And if people have questions about how to best do that, or about, I'm always happy to help external researchers, make use of our data sets.
Sure, thank you. There's a question on modes of recruitment for the different panels. So I guess opt-in panels use kind of different modes. Were there any differences based on the modes of recruitment, maybe specifically for the opt-in panels? Did you find?
So the opt-in panels. Well, I guess the probability-based panels that we looked at are all currently recruited using address-based sampling.
Sure.
They have some different methodologies in terms of the particulars, but that's the primary mode for all of those. The opt-in samples, it's very hard to know. There's not a lot of detail about exactly how any of these people go about recruiting their samples. So it's not something we could really look at. This is something I would love to see greater transparency about from people working in that space, because I do suspect that it might be possible to sort of pin down some differences or identify some mechanisms if we had that data. But really all we know is that they are from variety of, opt-in online sources.
Sure. Okay. I mean, I guess just maybe one from me quickly, thinking of the people working in that space. I mean, has there been much reaction from those who are running these opt-in panels to your research, in particular, I guess the Holocaust example that got loads of publicity? I mean, it seems like it's bad news for them that that kind of when you could show that the over-reporting of some of these things would compare with your probability approach. Have you had any kind of reaction or feedback on that?
Just sort of, small things. I know none of this is, super news, I think, to anybody who's working in that space. I mean, I think generally everybody who's doing that kind of work really is trying to do the best job they can, and working on developing measures for identifying this kind of low quality data. So I think it's not, I think everybody sort of is interested in trying to identify and solve these kinds of problems. We've heard from a few people in the industry, and generally it's, people are interested in trying to, find solutions.
Okay. Okay, so on solutions, I guess we've got one question now. To prove whether the opt-in sample measurement error observation beyond doubt, you could ask the same question twice at the beginning and end of the survey, or even on separate ways with the same sample, and flip the scale. So e.g., how much do you agree the Holocaust is a myth? And then next time, and agree, disagree, and then next time, disagree, agree. Or even flip the question wording, such as a yes or no means the opposite the second time. So that's not really a question, but I guess a suggestion there. Is that something you thought about or looked at?
Well, so I will say that, the scale, at least in our replication, was randomized, in terms of it was agree first versus disagree first. It's not clear what was done in the original survey. I didn't see that in the documentation. But interestingly, though, in our earlier, we had a 2020 report focused specifically on the question of bogus respondents. And we found a lot of these kinds of patterns there as well. And at one point, though, after the data collection was done, we were like, well, actually, we hadn't randomized a lot. There was a lot of things where we didn't randomize the order, and there were certain other kinds of things that might have explained it that weren't actually in the original study design. So we fielded it again. We randomized everything, all the scale, the order. And in fact, regardless of the randomizations, we saw the same patterns appear of people saying yes to questions, and whatnot. So so it's something we've done. I think we haven't done something where we've tried to sample the same opt-in respondents at 2 different times. It also wouldn't surprise me if that would be you'd get a different set of people, potentially, the ones who can be, successfully surveyed multiple times. But it's a good question.
Sure. Okay. Maybe time for 1 or 2 more. So, if these bogus respondents aren't performing in a uniform way, what explains why they are consistently selecting the younger age group and Hispanic?
So I think there are a few hypotheses here. I think so. One, I think maybe that these are specifically hard to survey groups, right? And so if you've ever tried to sort of take some of these opt-in samples to try to get a reward or something like that, you will often find that you are repeatedly getting screened out and screened out and screened out, and there are already enough people in your particular group, right? And so if you're trying to earn a reward, I think some people probably know that if you say you are young or say you are Hispanic, you're maybe more likely to be screened in and be able to less likely to get kicked out. And I think there's been some studies that have found systematic efforts on the part of respondents to try to bypass screening questions. And I think this may also be what's behind some of the yes responses that we see in our data. So a lot of the questions, those yes/no questions, I think may have looked like we were screening to find particular rare groups, right? So maybe people who receive certain kinds of government benefits or people who are on workers' compensation. And so if somebody's trying to screen into this survey, they may want to say yes to those. It's also conceivable that this is just random for some people, right? But that if these are the last quota cells to fill up in an online opt-in sample, and there's some number of people out there who are just answering things at random, those people are potentially going to wind up disproportionately within those demographic groups. So I think there's a few different things that can be going on here.
Sure, makes sense. Okay, so it's 6 o'clock in the UK, I guess 1 o'clock or something where you are, Andrew, maybe quite a lot earlier.
2 o'clock. We're in that weird 3-week period where
yeah.
we've changed our clocks, but you have not. So
yeah, cool. But yeah, we'll wrap up there. But thanks for everyone for joining. Thanks very much, Andrew, for a really great presentation and for getting through as many questions as possible at the end. Sorry if we didn't get to your question. There's obviously a lot of interest in the topic. As Andrew said, the data is all available on the Pew website and the reports and so on. We'll be sharing the recording as well. So yeah, there's lots of opportunities. I'm sure you're happy for people to get in touch with you, Andrew, as well.
Yeah, absolutely.
Great. All right. So thanks everyone. We'll finish there, and there'll be another methods webinar soon. So hopefully see you again soon. Thank you. Bye bye.